Hi, today we're going to be working on 6.5, which is complex fractions. So let's begin. All right, what I want you guys to do, please remember, go through the notes and actually read all the document parts that are in the notes. I am going to go over the examples with you so that you have them. And complex fractions is just a big fraction divided by another big fraction. The way I do them is I treat them like a division problem. I don't like the way they look like this. So what I do is I take care of the numerator first, then I take care of the denominator. I try to simplify it the best I possibly can. So what I'm going to do is this. I'm going to simplify this a little bit easier. I'm only going to work with what's in the numerator right here. So that is 2/5 plus 1/4. So I'm going to find a common denominator. The common denominator will be 20 because 5 times 4 is 20. Now, 5 times 4 gives me 20. So whatever I multiply the bottom by, I got to multiply the top by. 4 times 2 is 8. Now, 4. What would I do to 4 to get 20? I times it by 5. Whatever I do to the bottom, I've got to do to the top. So I get 5 here. So now my denominator is 20. 8 plus 5, 8, 9, 10, 11, 12, 13 is 13. So my numerator is going to be 13 over 20. Now that just looks better. Now I'm going to do the bottom, the denominator. I'm going to do this part right here. So over here I have 1/2 plus 1/3. I'm going to find a common denominator. I'm just going to multiply 2 times 3, which is 6. So now what I'm going to do is I'm going to multiply 2 times 3, which gives me 6. Whatever I do to the bottom, I got to do to the top. 3 times 1 is 3. Now, what would I do to 3 to get 6? I times it by 2. Whatever I do to the bottom, I've got to do to the top. 2 times 1 is 2. So that one's going to give me my denominator 6. So 3 plus 2 is 5. So this is going to be 5, 6. Now, this just looks really weird to me. It's 13/20 divided by 5, 6. I do not write it that way. I rewrite it as this. 13 over 20 divided by 5 over 6. To me, I can see it more clear. So we leave the first fraction alone. We change the division sign to multiplication, and we flip the second fraction. Now at this point, you reduce it if you can, and I can. This diagonal, they both share a 2. 2 goes into 20 10 times. 2 goes into 6 3 times. Now they don't share anything else. So I'm going to multiply across. 3 times 13 is 39, and 10 times 5 is 50. 39 and 50 don't share anything else. That's my answer. Okay? All right, next one. Simplify each complex fraction. Well, the way these look, I can't add these together at the moment. They just look weird. So what I have to do first is I have to take what's up here, and I need to combine them. So that is actually m over 1 plus 1 over 2. I need to get a common denominator so I can add those two things together. So what I'm going to get is 2 is my common denominator. So I'm going to multiply this by 2. I'm going to multiply this by 2. So in the numerator, it's going to be 2m, and then this is 1. So this is going to be 2 is my denominator, and my numerator is 2m plus 1. So this is going to be 2m plus 1 all over 2 divided by. So now I have to take care of the denominator. Well, the denominator is already done. It is, I could actually factor it though. Well, I'm just going to leave it for right now. So that's going to be 6m plus 3 all over 4m. The reason why I didn't worry about factoring it now is because I know that they share a 3, but that doesn't help me with this on the denominator. So now, I don't like the way that looks. So I'm going to write it out as 2m plus 1 over 2 divided by 6m plus 3 over 4m. Now, the rules are, I'm just going to do it over here. I can't do anything with the first fraction at all. I'm going to change the division sign to multiplication. I'm going to flip my fraction. So my 4m is now in the top. I do notice that the 3 and the 6 share a 3. So I'm going to factor out a 3, and that leaves me 2m plus 1. Now, if you notice, because it's a division problem now, this whole thing cancels to 1, and this whole thing cancels to 1. This 2 cancels to 1. This 4, 2 goes into 4 twice. So I'm left with 2m, and on the bottom, I'm left with 3. And that's it. All done. All right. Another one. Okay. So on this one, oops, I forgot to reset this so I can do my timer so I don't go too many problems over. On this one, again, it looks really weird. I cannot do this math problem the way it looks. So the way I'm going to write it is, and there's nothing I can do on this one, it's just going to be m squared n to the third over p divided by m to the fourth n all over p squared. So by writing it like this, it just looks better. For me, it looks better. So I leave the first fraction alone. Don't touch it. Just rewrite it. Change the division sign to multiplication. Flip the second fraction. Okay? Now, if you can reduce it, please do. However, I personally don't. I multiply. Whenever there's just a bunch of variables, it freaks me out. So I take care of it at the very end. I don't know why, but I've always done that. You can do what you want, but that's what I do. So I'm just going to multiply the numerator together. So I get m squared, n to the third, p to the second, all over m to the fourth, n, p. Now remember from prior past that we've worked on exponents. Whenever you, or powers, whenever you divide powers, you subtract the exponents. So I'm going to start with my m. I get m squared divided by m to the fourth. That gives me m to the negative second. 2 minus 4 is negative 2. Now I have n cubed divided by n cubed divided by n to the first. That gives me n to the second. 3 minus 1 is 2. Now I have p squared divided by p. 2 minus 1 is to the first power. Now, I cannot leave this the way it looks. I can't have a negative exponent. So I'm going to bring this down here, and then the other ones stay upstairs. Okay, so it's n squared times p all over m second. All right, I think I'm going to do one more, because I think we have a ton more. We do. So I'm going to break this up into 2 videos. I'll be here for, if I can find the, well, good heavens, where did they all go? I know I wrote them out. There they are. I'm like going, where'd they go? All right. They started to look the same. I'm going to stop here because I think I have been going through them. No, maybe not. There's 2, 3. Okay, let's do some more problems. We have more time to go. All right. Same thing on this one. What I'm going to do is I'm going to combine all of this first before I do anything else. So 1 over a plus 1 plus 2 over b minus 2. I cannot do anything with that up in the numerator until I clean it up a little. So I'm going to have a common denominator. My common denominator, they both have to have an a plus 1. They both have to have an a plus 1. They both have to have a b minus 2. They both have to have a b minus 2. So what's missing up here? Well, what's missing up here is, how can I write that? It's missing a b minus 2. So if I multiply this by b minus 2, I've got to multiply this by b minus 2. So up here, it's going to be b minus 2 because 1 times b and 1 times negative 2. Now here, what's missing is a plus 1. Whatever I do here, I must do up here. 2 times a is 2a. 2 times 1 is 2. So my denominator here is a plus 1 Whoops, I don't know what's happening. And then this is going to be b minus 2. And then above it's going to be 2a plus b. And that's it. That's all I can do. That's it. And there's nothing else I can do with the numerator. Now, with this denominator here, I personally don't like it that it's a subtraction problem, so I'm going to change that to addition, make that its opposite. Now let's do that one. So I have 2b minus 2 plus a negative 1 over a plus 3. So again, you got to have a common denominator. The common denominator, they both have to have a b minus 2. No big deal. They both have to have a b minus 2. They both have to have an a plus 3. Okay? Now, what's missing here? Well, a plus 3. Whatever you do to this, you must do to here. So 2a, 2 times 3 is 6. Now here, you're missing a b minus 2. Whatever you do here, you must do here. Negative 1 times b is negative b. Negative 1 times a negative 2 is a positive 2. So now, my common denominator, I'm just going to write it here, is b minus 2, a plus 3. That's my common denominator. And I get 2a minus b plus 6, 7, 8, plus 8. That's weird. Okay. Now, oh my goodness, we got to still go. So what you're going to do is you're going to have 2a plus b all over a plus 1 times b minus 2 divided by 2a minus b plus 8 all over b minus 2 and a plus 3. It's a lot of work, you guys. All right. So again, we rewrite the first fraction exactly the way we see it. We change the we change the division sign to multiplication. We flip the second fraction. And, all right. So if you can cancel something out, you do so. The b minus 2's cancel out. There's absolutely nothing else you can cancel out. That's like it. It's just nothing else you can cancel out. So your answer is going to be 2a plus b times 3a plus 3 all over a plus 1 times 2a minus b plus 8. And that is it. Can't do anything else. Wow, that's a lot of work for one problem. All right, I'm going to go ahead and stop there for a moment. It continued for some reason. I don't know if I have time to finish those. Well, I'm going to just keep going. I can't remember how long it's been since, I just don't want the video to be super long. So, yeah, I'm going to stop here. All right, I'll see you shortly in video B. You guys have a great day, okay?